Raghu, is anyone is going to join, or shall we start?
So you can start proceeding. Most of them have joined. If one or two, I guess they will be joining during the session. You can go ahead.
Okay. So the one request from all your side is that please mute your because it is echoing from my side. And so myself, Shrikant, and I'm working as a lead data scientist in GeoMind IT Solution. So coming to my background, I started my career in Axis Bank as a data analyst. So where I did a lot of forex transactions and forex analytics related to the foreign exchange and the trade. And later on, I joined IBM for computer vision developer. So where I work on most on the Watson Studio and many things. So then I joined the Innomatics as a research developer. Then I was currently working as a lead data scientist here. Okay, so what we are basically discussing is that we're trying to understand the data science, and I'm dealing in a different way. Like first I'll explain about the application. First I'll explain about what is data science. Then I will try to explain you the image processing basics, and finally we will try to create one application. That's what the idea. And roughly it will take around 1.5 hours from here when I start. And so if you have any questions or any doubts in middle, just raise your hand so that I can see. Okay. So hope everyone is clear. And okay, Raghu, can I start now?
Yes, sir. You can start now.
Okay. So let's start. One second. Yeah. So before starting this data science, I just like to ask you a question like, what is data science? What do you know about this data science, and what do you understand about this data science? Can anyone tell me?
Like as per my knowledge, can know that data science is the total information which organization is holding. Like maybe it will be transaction based, like customer based.
Okay. Okay, good. Okay, any answers?
Data science, in short, is all about finding insights into the data that is available using different machine learning algorithms or automated. Machine learning is nothing but automated algorithms.
Oh, okay, good. And anyone want to share?
I don't know, maybe study of data.
Yeah, study of data. Okay, very simple and perfect answer. And yeah, Praveen, you want to say something? Okay.
No, I just did.
Yeah, sure. Yeah. So okay, forgot about data science. What is science? What do you know about science? So data science is maybe some particular word. What is science then? Science is about study of some facts, right? Science is really about study about some facts or something. So in a simple terminology, data science is all about studying your data, studying about data, get understanding data and insights from the data. So each and everyone also can share something about data. And all are correct. It's all about studying something, studying about the data. Okay. We know that our world is changing in a different way. One thing that is changing our life is artificial intelligence. AI is bringing a new industrial revolution. Previous industrial revolution expanded human mechanical strength, like motors and industries improved our mechanical strength. But this industrial revolution expanding human cognitive power, that is ability to think. See, for example, can you tell me any device like which improves our ability to think or something? Anyone? Which improves your cognitive ability to think, something like that. Or you can tell me any AI device which improves your cognitive ability, which makes you to do some. Anyone want to share? No? Okay. See, can I tell you an example like, calculator is a simple AI device which improves our cognitive ability. Calculator is also an AI. Call it calculator. We can call it simple calculations which can also do some subtraction, multiplication. It's not that we can't do. We are making use of the machine and do our math simple and very simple calculations so that we can consider some other things. AI or artificial intelligence is also same, which improves our cognitive ability. Can you tell me this? Do you know this game? Anyone?
Which game?
Anyone know this game? Yes, please. Okay. See, this is the game called Go. Actually, it was invented by Chinese, and mostly people used to call this is a Chinese chess. This is the most difficult game, in terms of thinking. Only human can play this game, not machines. Machines can't able to play this game. But in 2016, a program named AlphaGo created a history that it defeated the old championship in that game. You know that it making a statement that machines start thinking actually. From there, in 2016, you are hearing that with the most of the buzzword like data science or artificial intelligence, you heard more about after 2016, right? So it's all because of this. This is what the is the revolution. It's created artificial intelligence, a neural network, whatever no, it's not new. It's very, very old technologies, and all are it was invented or it was discovered around in 1958. Around that particular time, it was invented. But this algorithm makes some small changes into our math and created the sensational history in 2016 and making a statement that machines start thinking. And okay, that is what the machine learning algorithm. Actually, how that machine learning algorithm learns. Any machine learning algorithm learns from the data. Data is information. So this is what the process of learning from the data. So once you have the data, means you have the information that enables the knowledge, and finally it gives you the intelligence to it. See, once you have the intelligence, means you can take some actions, right? For example, most of the people, maybe you are experienced people. So maybe in the day one of your, in the day one when you're in your working experience, maybe you don't know anything about that. What you are trying to do, what's happening and all. You don't know anything, but maybe now you know what is happening because you have the information and you have the knowledge of that. And finally, you can, if any problem occurs, you can take the decision or you can give the suggestions to someone, or what are the actionable things you have to do, and also the consequence on that. So that is what the process of learning from the information we do. We actually learn from the information. We actually learn the same process we are actually dumping into the computer, and that is what we are doing. So the definition of the data science is process of learning from the data or process of extracting knowledge from the data. That is called the data science. Data science is basically the process of extracting knowledge from the data. And in that, we have the process, data preparation, data analysis, and some machine learning or deep learning models. So let's talk about the data bit. So, you take any data, any raw data, like it's like a puzzle. Any data you take, whatever the data, it's a financial data, images, or what not, what kind of data you want to take. It's a puzzle. How we solve some puzzle? Basically, let's say this is what my jigsaw puzzle. How we solve such kind of puzzle? Mostly, right? You might solve this puzzle maybe from taking the starting point or the ending point. Maybe basically we're trying to organize it, right? First of all, what we are trying to do is that we're trying to organize that. This is what are the data we have? We'll first organize it. First, what we are trying to do is that we'll try to organize the data. So means first we're trying to find out what is the starting or what is the ending, that we're trying to find out those cubes, and maybe the part of information was there which also lies in some cube, and keep on joining that, right? So this process is called data preparation or pre-processing. And finally, while doing that, you're trying to create some picture like this. And try to remember one thing. See, what are the data you collected? It may not be completed. Let me give you something like, second. Yeah. Oh. Okay. Let me tell you something like, let's say you want to build one application like fraud detection. Fraud detection is what the application you want to build, and the output of that is that the machine learning algorithm should identify the fraud, and it should know whether the transaction is happening the fraud or not. So can anyone of you tell me if suppose you're making one transaction, and how can machine learning algorithm learn, or forget about the machine learning, how you know that this transaction is fraud or not a fraud? How you know that? Let's say you withdraw some amount or something happened. So how you know some fraud transactions from your side? Anyone?
Am I audible?
Yeah, tell me.
So we can check with this previous transaction details, one with the previous transaction details.
Okay, see, the thing is that it's not like that. So for example, you transfer, from your account, some 50,000 rupees is transferred from your side without knowing you. Such kind of transaction is called fraud transaction. Okay.
Pattern. You'll check with the pattern whether.
What pattern? What kind of pattern you're talking about?
So the type of transaction, the outliers, the factors that.
So can you please elaborate?
It can be any factors, right? Something like the location of the transaction,
Okay.
where it happened, or
okay. Let's discuss and let me take the data. Okay, location is one feature. Okay.
And the devices that were used are IP addresses, or
IP
if it is
address.
an
Okay.
direction.
Yes. Correct. Okay.
And the previous somebody was also saying kind of this previous transactions history, right? Whether that
previous transaction amount maybe, right?
Yeah.
If I'm wrong.
So
okay, previous amount of what you actually used. Okay. And you might also have account number. Yeah, that's also data, right?
Yeah, where was the data transferred to, and whether there was
account number, beneficiary account, and okay. Yeah,
so
account number. Okay, phone number, account number, phone number. Sorry. Mobile number. And you might also have name of the person. It's not disturbed.
Yeah.
And etc. So many, there are a lot many data of that. Out of this, which is important to identify the fraud? Which is important to identify a fraud?
Number 4, maybe.
Number 4, account number.
Yeah, whether the account is used in the past or not.
Suppose you are in the situation in the machine learning. Let's say if I put you're in the situation of the machine learning algorithm, how we identify fraud? So let's say these are the factors for the. Let's say these are all the factors for the. Which is important to identify this transaction is fraud or not?
Maybe number 1 and 2. Where was location and the IP address? Where right? So maybe I'll because we sometimes actually transfer money to.
Yeah, correct.
Random accounts too. So that cannot be the primary primary, I'll say, factor.
Okay. Yeah. So let me give one scenario. Your answer is correct, sir. Let me give one scenario because other people have to also understand that. Let's say today now time is around 7. So let's say 7:20 is the time, and I transfer, and my location is Hyderabad, and my location is Hyderabad. I transfer some, let's say 50,000 account to 50,000 rupees to my friend. Okay. So let's say let's say 8 p.m. And the location it shows me is, and the location is, let's say it showed me, let's say New York. Okay, the location is New York, and the amount that is transferred from my account is, let's say, 1 lakh rupees. Okay, is this transaction is possible? Is this transaction is possible? 7:20 p.m. and this is what the transaction I did, and this is what the transaction fraud was. Is this transaction is possible? Second transaction, maybe the first transaction is possible, but second transaction is not possible at all, because in 40 minutes I can't travel from Hyderabad to New York. It's almost take for almost 12 hours, minimum 12 hours it will take for me to go from this place to that place. So and this is what the idea of that. So what we're trying to do is that previous transaction, that's correct. Actually the previous transactions, based upon the previous transactions, whoever said is the previous transaction is correct, but I just want them to elaborate this. So from the previous transactions, we can easily identify whether it is a fraud transaction or not. Because from the previous transaction, I said is that the location and the time, it's all together. It's not the single feature. It's all together. We have to identify the fraud. So this is what the basic analysis. Without building the model, we can simply build okay, current location is Hyderabad, and after 20 minutes, and the new location is New York, and within this time period, it is impossible for him to move from one place to another. So from that, we can deny the transaction, saying that this is a fraud, and so on. So like this, what we can do, maybe the IP address is also comes, and also the amount, previous amount is also the answer, because we track the people, what is the spending amount. Suppose the average spending amount of the person is around 10,000 rupees. If the amount is more than below the outliers, whoever said is outliers is correct. So beyond the outliers, we detect that it is a fraud. That's a possibility of the fraud. So that is what we are trying to understand in the analysis. And at the same time, when it comes to the data perspective, we never have, let's say if we sit on discuss, there might be the 100 parameters out there affecting the fraud, but there will be the 101 parameter which we have not discussed. Correct? So that is what I'm trying to explain here. So what are the data we collected? For example, fraud data you take. What are the data we collected? We go back and collect all this data. And what we'll have is that we have only the few data. We have only the sample of the data is what available from us. And from the sample of the data, we need to fill the gaps. From the sample of the data, we need to understand, we need to analyze the situation, how each factors are related towards my fraud. That is what my target variable. How my transaction is related to that fraud, and all these things. This is what we are trying to do in the data analysis. So for example, what kind of analysis you can do in this picture? Maybe it is the evening, two gentlemen are riding a bike. Maybe they are riding a bicycle, and some sea, and maybe see what kind of picture can be here, between these two. What is a possible picture is there? Maybe two hands or joining or giving the high five or so on, right? So that is what the analysis, that is what the insights we're trying to draw. So finally, we draw the insight. Insights means trying to fill out the gaps. Insights means trying to fill out the gaps. So that is what we're trying to do in the data analysis lifecycle. From the raw data and getting the insights from the data is called data analysis. Here we have some kind of process out there. First is data understanding, data preparation, data analysis and visualization, and finally we draw the insight. Data understanding is basically deals with a lot about the statistics. Statistics, in a simple terminology, you want to say, like, we'll talk about the three things: how to collect the data, what are the data you need to collect. For example, in our here, for example, this is, let's say if you talk about this, what are the data you want to collect? See, for example, you want to build the fraud detection. Maybe the bank will give the what are the data you want. Maybe they might give, but they don't know what are the features that might affect the fraud. We need to identify that. What features are really important? What are the features? So what are the possible features we need to collect? That is what we have to do. That is what we'll talk about. How to collect the data, analyze the data, and drawing the conclusions from the data. That is what the business here in the data understanding. It's totally deals with the business understanding. We should know about what is the business, and we should understand, at least we should have some basic domain knowledge in that particular field. Then only we can know that what are the data we collected. We can do analysis much better. If you don't know about that, what is the data, if you don't have any domain knowledge on that, maybe it's very difficult to do the analysis. So before doing analysis, we have to understand the data first. And later on, what we will do is that we will do the basic data pre-processing steps, like cleaning the data and all these things. And mostly, see, it's not only the Python is what is being used. There are many. You can also work on the Excel sheet. You can also work on the SQL queries and a lot more. It's basically what you're trying to do is the extract, transform, and loading. ETL process, let's say if your data is in the database, you need to pull from the database and do have to do the necessary transformations like cleaning the data or applying some kind of transformations like dimensional reduction technique or whatnot. Okay, and finally, we will load the data into the database. It's not only the Python language is being used. You can use whatever language you can for doing the pre-processing. You can use Python, R, and you can also work on even the JavaScript, many things. It's not only this. And maybe this process can also be done in the Hadoop ecosystem too. Okay, yeah. And finally, we can do the analysis like this and finally draw the insights from the data. Okay, we got the knowledge. What we have for the fraud transactions, we got the knowledge now. If you want to build if you want to build an application for the fraud transaction, I know, okay, these parameters are important, and I know the basic rules. What are the rules I need to form? I know it. But see, I want to transfer my knowledge to the machine. I can't sit and I can't analyze, okay, this is the fraud or not, whether it is having in my rule or not. I can't verify all the rules. Something has to be done because there are millions of transactions being happened maybe in a hour. So machine has to understand that. Okay. From the knowledge, we want to predict the unknowns. So what we have to do is that what we have to do, what are the knowledge we have, and machine has to take the decisions, not us. Okay. Machine learning, this process is called from the knowledge, means process of learning from the insights is called machine learning algorithm. Basically, that process is called machine learning. Okay. Here we have the few techniques out there: regression, time series, classification, clustering, association rules, and many things. So these are all the techniques. And inside there are many algorithms out there. But in regression, maybe there are some 10 to 15 algorithms out there only in the regression and time series and classification and so on. So let me give the basic idea of what is regression, time series, classification, clustering, and rules. Let me take each example for each one of the algorithms. For example, let me take the regression. Most of my, as I said, I was working in the banking industry. Most of my banking industry, I work only on the two algorithms, regression and the time series. Only two algorithms I worked on. Only two algorithms I worked on. Moreover, in my banking field, mostly what I am trying to do is that it's completely related to the foreign transactions and like that. And many people comes to the bank, they will ask me to book a USD maybe 6 months in advance or something like that. See, it's very difficult. First of all, it's very difficult to predict anything more than 1 week or something. Suppose most of the people comes to the bank, they'll say like, because they might do some kind of imports and exports business, but there is nothing wrong for them. And they will come and ask me like, okay, you just book me a dollar price 6 months in advance. You tell me like, what could be the dollar price after 6 months, after 8 months, what could be the dollar price, so that he might take a decision whether he want to take the dollar now or some other time. Okay. So that's and I can't say like, I can't say like, because I can't predict the dollar in 6 months. I can't say that, because if I say like that, obviously I lose the business. If I want to predict something like, dollar price in 6 months in advance, how can I do such kind of prediction? First of all, predicting anything is very difficult, right? This is what obviously any bank will do. So the concept of modeling is like that. Concept of any machine learning model or deep learning model is something. It's like that, from easy to measure parameters, we have to predict the hard to measure. For example, if you take like, age, gender, income, education level, these are all easy to measure parameters. And the difficult to measure parameter is how much of amount I have to give to him, whether he will buy the product or not, how many days a patient will stay in the hospital or not. These are all the difficult to measure parameters, but easy to measure parameter is this. So any concept of modeling is like that. For example, I talk like, dollar price, how the dollar price will wait, like, how can I predict the dollar price? If that is the case, first of all, we have to understand, like, how the dollar, what are the factors that dollar will vary? How the dollar price will vary? Any idea, anyone, how the dollar price varies? USD? Any idea, guys, how dollar price will vary? Okay, fine. See, so basically, the dollar price is it totally depends upon the economical condition of that particular country. Okay, also GDP, you can take GDP or fiscal rate or something. It highly depends upon the GDP of that particular country. That is what the strength of the economy of that particular country, and also depends upon the central bank interest rate and country debt level and so on. So first of all, of course, the strength of the economy is what the factor that highly depends upon the dollar rate. But how to add what is the strength of economy? Anyone knows what is strength of economy? Yeah. Am I clear? Okay.
Yeah.
See,
GDP.
Yeah. GDP. Yeah, correct. The strength of economy is talks about the GDP, gross domestic product. What is that actually? Anyone?
It's the market value of the goods produced in the country, maybe.
Okay. Yeah, correct. But in the simple terminology, the strength of economy or GDP is about cost of living. It's all about cost of living of that country. Simple terminology. If I want to say, if I want to put it very simple, it is strength of economy is all about the cost of living of the country. We all know that the cost of living in USA is very high, and the cost of living in India is very low compared to USA, right? Correct. So okay, so actually, that is what the strength of the economy. That is what mostly the strength of the economy is mostly talk about GDP, or in a simple terminology, cost of living. For example, how can I measure that cost of living? It's very difficult. Measuring the cost of living is really very difficult. In a simple terminology, cost of living means on an average, how much money I really require to eat sufficiently, food, or to live particularly in that country. That is what a simple terminology, the cost of living. For that, generally, the cost of living, how they'll calculate is that they'll take one basket and take all the fruits, vegetables, and what is the price here, and also what is the price in that particular country, and so on. But here, it's very, very difficult to measure the cost of living of that particular country. Most of the banks, like, World Bank suggests that this one. World Bank, what they suggest is that since it is very difficult to measure the cost of living of the country, we can do something like Burgernomics. Nothing but simple. Burgernomics is what, they will take the hamburger, like, a hamburger, McDonald's hamburger. And this is what the McDonald's hamburger is, what the index for measuring the GDP or cost of living of that country. Most of the people, most of the banks will do, almost all the banks will do the same thing. How they will do is that they'll do the simple thing. Like, let's say I'm having $100 with me. How many burgers I can purchase in India? How many burgers I can purchase in USA, and South Africa, Thailand, Mexico, so on. That is easy, right? So why they'll take burger? What is the reason of considering the burger? And also, what is the reason of taking this McDonald's? The reason of considering this McDonald's is the only restaurant in the world which is almost there in 130 plus countries. No other restaurant is there. None of the restaurant is there more in 130 plus countries. Since that is what the common thing, that is what the common metrics, that is what the common thing that is available in throughout all the world. So that's why they will take this burger. And that too, they'll take the hamburger. In India, it is called Maharaja burger. And they'll take this Maharaja burger and they'll measure the price, let's say in 2018, what is the price? And in 2019, what is the price of the Maharaja burger? And in 2020, what is the price in the Maharaja burger? And why burger? Why they take this burger? See, if you take this burger, like, the burger, if you analyze the cost of the burger here, almost everything is there. Like, it consists of like electricity bill, maybe the tax, local tax involved in that, transport tax, everything, and even the profit, they also include some profit, some X percentage of the profit, and finally they'll create, like, they create the price tag for that particular burger, right? So now you can see that. So if I have $100 with me, how many burgers I can purchase in India? How many burgers I can purchase in USA? That's simple. That's a very simple metric. So what we can see here, India I can purchase 61 and USA I can purchase in 23. This was taken almost, it's like 2 years back. This is what the picture I took. And so maybe the price will vary now. And so it's now it is, we can know, like, okay, in 2018, maybe I can purchase 60 burgers. Maybe in 2019, I may purchase 58 burgers. And 2020, I might purchase like, some 62 or 63 burgers. We don't know, right? So once I have such kind of something like this, something like, the burger price with respect to like, years. Now, this is what, let's say I collect the previous data. What is the price of the burger price? I put some scatter plot, something like this, and x-axis is the year. Now I can simply draw I'll try to find the relationship between with respect to X and with respect to the burger price. I'll approximate that is what, the economical strength of that particular country. See, I can purchase with, that is what the economical strength of that. Now you can see, I can simply try to draw a line. Okay. Now what I can say that, economical strength of this country is keep on increasing. That is what simple. That is what at some rate, year on year, this is what the economical country of that particular country is keep on increasing. So this is, let's say, if it was increasing at 2% or 3%, now it is easy for me to understand how the dollar price will vary. For example, now let's say 2% means, let's say in 2019 the dollar price is 70 rupees, and 2020 I can say like 2%, maybe roughly 72 or 73 rupees might be the case. But of course, it may not be every time. It may not be the case. But roughly, you can estimate that this is what the rate of change in the dollar price that we can able to do. So regression is an algorithm. Regression is an algorithm. We'll talk about relationship between two or more variables. That's what the regression. Whenever you want to find the relationship between two variables, for example, that is what the concept of modeling. See, easy to measure parameter is burger price. That is very easy to measure parameter. And hard to measure parameter is GDP. It's very hard to measure parameter. And also the hard to measure parameter is also the dollar price. So in order to understand the GDP or something like this, we're trying to find the relationship between the two variables. So here we're trying to find the relationship between the two variables with, a single line. Regression is what the regression will talk about. A relationship between independent features and the dependent variables. That is what the regression algorithm will talk about. In simple terminology, it always talks about the relationship. And coming to this, stock markets and all, let's say this is what the Infosys stock market, if you have. And in this case, the regression, in x-axis, what we have is the time, and y-axis, what I'm having is the price. Regression will talk about the trend. Regression will talk about the trend in the data. Regression will talk about this. This is what this line is called regression line. It will only talk about whether it is increasing or decreasing. That's what the regression will talk about. And time series is also comes from the regression algorithms. So all the math behind the time series algorithms is all came from the regressions only. But here we'll do some kind of analysis, like mostly in the time series, we'll talk about the three things. First one is trend. Second one is seasonality. And seasonality. Next, third one is random. These three things mostly you will learn about this time series. Trend is this is what the trend. This line it talk about maybe what you can say from that past from 3 months. What we can understand is that this stock prices keep on increasing. But here, see, that's not only important for me. Seasonality is what the trick mostly the time series people will do. As you can see here, the seasonality effect is clear. You can see my mouse, like there is a clear seasonality effect is there. See, one day, maybe 1 week it is increasing, other week it is falling down, and again it is increasing, falling down, increasing, falling down. That is what the seasonality will talk about in the time series application. Trend will only talk about whether it is on a whole it is increasing or not. But seasonality will talk about this. Seasonality, when it will increase and when it will decrease. That is what the season. It's following the seasonality effect or not. That is what mostly you'll try to understand the time series. And third one is random. Of course, we can't able to predict. It's completely random. Some kind of noise in this. It's completely random. That is what we can't able to find. So that is what times in a simple. That's what the time series. Regression will talk about the trend, and time series will talk about seasonality and the randomness. When it will increase, when will it decrease. Now let's discuss about the classification. There are a lot of applications of the classification. It was there in the telecom industry, retail industry, insurance, banking, and so on. We'll discuss more about this classification technique in the face recognition application, since we are mostly working on the classification. So the application of the classification is that, let's say if you take the Gmail spam detection and all, and mostly in the Google is a perfect example. Gmail is a perfect example of the classification. The Gmail algorithm knows that whether the mail that was coming to your inbox, coming is it is the social. Maybe if the mail is coming from the social, like social media websites like Twitter, Facebook, or something, it will move into the social. Or if it is came from some authorized dealers like banks or life insurance companies and all, it moved to the promotions. And let's say if apart from them, like some normal those who people do some promotions, it will move to the spam detection. It's not that people stay in the company, stay in the big Google, like they'll read your mails and understand whether it is a spam or not. Its mission is doing that. Mission try to classify whether it is the mail is a social, or it is from the promotions, or it is a spam, or it is if nothing, it will move into the primary folder. So that is what the perfect example of the classifying whether it is something like that. And also face recognition, like detecting male or female, and name of the person, etc. This and all the application of this classification. Next, talk about this one more algorithm, clustering and rules. So this clustering and rules, there are a lot of applications. One of the applications that was used is the recommendation system. This recommendation system, this is very simple. Like, it will talk about, it says that if you purchase one product, you will also purchase one more product. Like, if they'll talk about market basket analysis. And that is same thing they applied in the YouTube, Amazon, or many things like, if you watch one movie, if you watch one more movie, you'll also watch one more clip. Let me try to elaborate that what it actually means. For example, just think that you want to purchase some bread. Okay, let's say you have gone to some grocery store like a Spencer or Big Bazaar or something, and you want to purchase a bread. What are the possible items you might purchase? I say you purchase bread. What are the possible items you might purchase? Could be jam, could be butter, could be milk, right? Jam, butter, milk, and etc. Right? This and all belongs to one cluster. Cluster means group. Now, what I can say, let's say I want to purchase a jam, butter, so bread. Now that bread is in one side, and just try to understand. Just go to just go and see never this bread, butter, jam, never put one in one place. Generally, most of the cases, they never arranged in one place, because if you arrange them in one place, you straight away take this bread, butter, jam and straight away go into the bill counter and nothing else. So there is nothing improvement in the sales. Suppose if you put bread in one place, butter in some other place, and jam in some other place, and in between that bread and butter, if you put some offers buy one get one free and etc. So okay, he will take a bread, and in between he might see some buy one get one free. Maybe intentionally you creating the thoughts of course that is not useful for me, but in some other time it might be useful. That is possible. That is what, see, how the stores is being arranged is also about the machine learning algorithm. Just think, just go and think, just go and casually have just watch that how the store, how the items is being arranged and all these things. It's all about the machine learning algorithm. That is what the clusters and rules. Okay, the rule is simple. If I know this is one cluster, never arrange together. So like this, we can get the lots of the rules recommendation. Okay, if the person purchases the bread, it is recommended that he will also purchase jam, and he also purchase one bread, butter, and so on. And same thing that is also applied to the YouTube, saying that okay, the person watches the comedy clips, and it mostly that YouTube is highly depends upon the user ratings and also similarity between the users. So like you, suppose you love some comedy clip, and like you, so many people out there also watch the comedy and also like that. And what did you try to do? Okay, this person and this person watch the similar things, and most of the clips or most of the videos that watch are similar. So maybe, and what they will try to do, they'll try to recommend that, okay, this person did not watch the movies or clips by this person, so I'll recommend this to him, and the possibility that he will like it. So that is how that is what the idea of that, if you watch one movie means, like you, there's so many people are because you belongs to one cluster, so many people are there, already watched something, already watched some clips, and they keep on recommending to you. So that is what the collaborative filter approach is basically is. So you can sometimes whenever you watch the YouTube, some new clips, or it's not the clips that watched by you, it was the clips watched by someone else which are similar by you, which has the most similarity by you. So that is what the clustering and rules is about. Okay, and it also falls in the Amazon and all these things. But Amazon e-commerce, e-commerce website, how this recommendation system will work, because they won't roam, and most of the cases, maybe that is it will increase the sales, but mostly that e-commerce website will do the recommendations in a different way. They will generally recommend your data to industry. For example, you want to purchase one mobile phone. Let's say this is what the mobile phone you want to purchase. And let's say generally what you'll see if you want to purchase, you will see the specifications of that. What is maybe the camera, maybe the some features that was available to him, and so on. And of course, you never stop by just looking into the phone. You won't stop it. You will also see some other phone and also look into specification. Internally, what you're trying to do is that you're trying to comparing the two products. You're trying to comparing this product with some other product. Amazon will also do the same thing. They will track you. They will track what user is trying to do. What user is trying to search it. How many clicks he is doing that. Okay, he's watched this product and he also watched some other product with the similar quality, with similar price. Now, what he'll try to do is that he'll try to cluster that. Cluster means in here the cluster is price. Price could be the cluster. Maybe he's watching in the mobile, let's say mobile phone in the range of, let's say, less than 10,000. And let's say, okay, this person is watching the phones less than 10,000. What is actually interested in? He's interested in camera, or he is interested in, let's say, maybe some features, or what is actually is being interested in. That is what being analyzed by the Amazon people. And once they did this analysis, they will send, most of the cases, they'll sell to the industries, like some manufacturing industries, something like mobile manufacturer and so on. Like this, one mobile phone came into the market and still it is the number one in terms of sales is Redmi Mi. In India, Redmi Mi is number one in the sales, not in terms of quality. Of course, quality wise it's poor, but features wise, sales wise it is high. Because see, if we talk about the Redmi Mi, if you take less than 10,000 rupees phone, what are the features required by the user? It was there in that. For example, he want some 10,000, 15,000 rupees phone, and he has more features. Whereas if you take some mobile phones like Samsung, if you take less than 10,000 rupees phone, maybe you have quality of the phone is not that good. Maybe features, you might have some features. Let's say you take some other phone of the Samsung. Let's say the price is 15,000. See, generally the mobile phones of Samsung, there is not much change in the features, but there is a change in the quality. Nowadays, people are not looking into the quality. They are generally looking into the features. Because, most of the people, according to the survey, most of the people not taking the phone, withholding that phone more than 1 year. Most of the people changing their phone because new technology, new features are coming, and the people are interested in new technologies. That's what people are mostly use the mobile phones not more than 1 year. So that's why the people can taking the mobile phones Redmi, Oppo, etc. These are all still number one. The business is like this. Still Amazon, Flipkart, this e-commerce website, they track the people and they sell the recommendations saying that okay, people want this. You try to manufacture and you can get the more sales. That is how the Amazon or most of the companies like this, they're getting more and more money, like with just doing the basic analysis and creating the rules. That is what the cluster and rules. Mostly cluster and rules most comes together. And similarly, the deep learning technologies like neural network, convolutional, and the current neural network will come. Neural network is we can do regression as well as classification with a neural network. See, the basic idea of the machine learning and the deep learning is not that. Machine learning algorithms will deal with single model, but whereas the deep learning algorithm, it's also deal with the machine learning models, but with a multiple model. For example, if you consider the neural network, it's also regression, but you have some hundreds of regressions or connected together. It's called one neural network. Okay, and similar the convolution neural network. If the concept comes from the support vector machine and some kind of features and feature extractions techniques is there, and finally pass to the neural network. So the application wise, if you see the neural networks, we can do the problems like regression. What are the problems done by the regression, the classification, and similarly the convolution, we can do the regression as well as the classification. And recurrent neural network mostly deals with the terms of time and the text part. Of course, there are a few more deep learning techniques out there like Boltzmann machine, some advanced technique, Boltzmann machines, the self-organized maps, and so on. But those are advanced techniques out there. Okay, so that's what the idea of the overview of the data science. What actually the data science is all about. Since the data is everywhere, you have lots and lots of opportunities definitely in the field of data science. Okay, so any questions So that we will move to the face recognition. Any questions from here till now? Any questions, guys, till now?
No, it's good. Of course, we need to understand it. We heard you.
Yeah. Okay. So yeah. Now let's talk about. See, till now, what I know that it's a so many algorithms, so many techniques are there, and let's try to understand with an application what data science, what actually artificial intelligence, what actually machine learning try to do, how we actually learn, and what is the data. What I said, all these things. We'll try to put all together whatever we understand. Let's put all together, not all together. Maybe some parts might be missing. Let's try to understand with the face recognition. Face recognition, let's say, let me put one scenario here. Just take some business case because I just want to create one business case here. Let's say I'm having some grocery store with me, and in that grocery store, I want to put one camera, and I want to give some intelligence to the camera. Actually, I want to give some intelligence to the camera, saying that the camera can have to understand whether the person entering is male or female, and it has to want to count it. Okay, that is what the idea of the application I want to build. Again, I'm repeating. I'm having a grocery store, and I'm putting one camera over there, and I have to give the intelligence to that, and that camera should identify it's a male or female. Okay, I'm just trying to give the intelligence to that. Okay, fine. Okay, let's say you are in that position of the camera. How do you identify a male and female? By looking into the face, only face. I just want answers from, just possible answers, because you all know, we know the domain knowledge. The domain knowledge here is identifying the face. We know whether he is a male or she is a female. We know that. Now, I just want to ask casual question, since maybe most of the people, at least 20 plus, in 20 plus of years, most of the people are seeing humans, male or female. How you identify male and female? Only face. Yes, please. No idea? We don't know how to identify female or male?
Maybe the structure of the face.
Okay. Can you elaborate, sir?
How to elaborate the structure of the face? Maybe kind of the features of the face, if we can kind of look at it.
Okay. Okay, features. Okay, fine. Features. So,
Maybe.
Yeah.
Maybe if he's a male, maybe if you have a mustache or beard or some kind of stuff we can.
Mustache and beard. If I shave, of course I don't have mustache and beard. That's not the feature. Maybe. Okay, good try.
Yeah, by giving more feed to the machine.
Sorry, sir.
Yeah, by giving more images to the machine, like male images and female images.
Yeah, sure. Definitely, I'll give the more images to him. Of course, to the machine, definitely I'll give more images. But I'm not talking about the machine here. I'm just talking how you identify. I'm not just put the machine aside. I want you to identify how you identify male or female by only face. Some features are correct, but what are the features?
Features like the angle, actually the cheeks or jawbones and kind of
yeah, correct. Maybe soft, cheeks. Yeah, correct. So some pattern, some features, correct. Okay. See, that's the point here. See, we have the domain knowledge, but we can't able to express that. We know sometimes, this is what the problem. We know in subconscious memory, it was feed that, we know she is male or he is female, but we can't able to express it. We can't really express this. That's what the face recognition is, or anything. Most of the data, sometimes we can't, we know that, but we can't express it. Right? Okay, fine. So let's try to understand all these things. So now, how computer sees a person. Who is he? Is Dhoni, right? MS Dhoni. how computer sees a person, how computer sees Dhoni, Mr. Dhoni, this is Dhoni, how computer sees that. Let's say if I take this picture, how computer sees. Let's take let's take this picture and let's see. Let's say I'm working on actually some Python, and this is what the image. Okay. Yeah. Okay. This is what the image I'm trying to read in the computer. Now let's try to understand how computer reads a picture. Okay. Yeah. See, I'm working on a Jupyter notebook. Maybe if you join this course, most of the course is being taught in the Jupyter notebook. Jupyter stands for Julia, Python, and R. Julia is also language, and Python and R is a language. It's not just that they started with this, Julia, Python, and R, but actually, we can write so many languages in that. It almost about 30 plus languages can be written in this. It's an IDE. It's basically IDE. Okay. I'm just writing. I'm working on the Python 3 environment. No need to understand what I'm trying to write. Just try to understand process. That's it. Just you guys try to understand the process. Okay. Now, see, let's say I'm having the data with me. This is what the data. For my case, it's a data, and the name of the data is ms-dhoni.jpg. Okay. In order to read that image, in Python, I just want to import few libraries, mostly numerical Python, just called NumPy. And also I want CV2 is basically the computer vision library. Okay. So this is I just want to import few libraries. Now let's read that image, cv2.imread. So this is basic commands to read, and what I need to mention is that name of the file. Since I was in the same directory, that's why I just want to give the name of the directories. For example, if you have the data in your database, just provide the IP address of that. That's enough. Okay, so the name of the image is ms-dhoni.jpg. Okay, execute it, and the image is loaded successfully. Okay, before printing that image, what could be the answer, please? If I print this, what could be the values I'll get?
Bytecode.
Okay. Any other guess? Okay. Okay, fine. Let's print that image. This is what the image is. Some numbers.
Is it byte array?
Oh, RGB coordinates. Okay.
Yeah, RGB. Correct. It's numbers. It's a numbers. It's some random numbers. 210, 223, 237, 206. Some numbers. Some very big matrix, and it's numbers. This is how the data. As I said when I starting this, data is a puzzle. See, for us it's not puzzle. It's not puzzle for us. It's very easy for me to understand. Okay, this is MS Dhoni, but for computer, it's a puzzle. This is what the data for the computer it looks like it. Right? Clear? Okay. So first of all, since it is a puzzle, so I don't want to deal with such kind of puzzle. Let me look into the shape. Just try to summarize my data. If I summarize the data, it says that there are 512 rows are there, 640 columns are there, and the 3 indicates the depth. Okay, 3 indicates the depth. It's basically RGB. But here I'm using the OpenCV. This is OpenCV, please. This is the library. What I'm using is OpenCV RGB. Sorry. RGB, GB, sorry, GB. Okay. Since I'm using the OpenCV, basically OpenCV reads in BGR, means blue comes first and followed by green and followed by red. Okay. What I'm meaning is that let me render that image. So let me display that image so that it will be clear. I'm just using the visualization library like Matplotlib. You can also do the powerful visualizations in the Python from import matplotlib.pyplot. So you don't need to understand the code. All these things you can learn all this. SPLT and line. Okay, and image. Okay, this is what the image is for me if I display it, because it is reading in BGR. Actual original image is this. original image is this. Doesn't matter. See, we are never deal with colors. Doesn't matter. What it means is that the first color is treated as a red. Basically, the first color here, what we had is a red, green, and blue. And whereas in this picture, in BGR, like OpenCV reads in BGR format, means red is replaced by blue, and green is green, and green is green, and blue is replaced by red. That's what it means. Okay, so that was represented by number 3. 3 indicates BGR. It's a third dimensionary. If we see, maybe you might studied about in your BTech, or maybe in your graduation, or even in the lower classes, intermediate or something. Maybe you studied about 2 dimensionary, right? You might study rows and columns, but this is a third dimension. This is mostly the images or third dimensionary array. This is basically what the data is, that it's a third dimensionary. Okay, it doesn't matter with the colors. See, this is what the image what I'm having. The first, you can see the first column what you see is B, and second column what I'm having is the green, and third column what I'm having is the BGR, red. Okay, see, for the case of simplicity, what I will do is that let me take this image for the sake of simplicity, since it consists of red, green, and blue colors. It's easy to understand and also analyze. I'll read this image and try to just few seconds. Let me just try the few minutes. Let me explain that. Then we'll go into the actual concept. Image 2, the image2.jpg, and if I print this is again it's the numbers, and .shape. If you see that shape, it has 343 rows and 470. Doesn't mean this is nothing much width and height of the image. Rows indicates height, and columns indicate width of the image. Okay, now let me plot it, and this is what I'm having with me. It's a BGR. This is what the original image, and this is how it's represented. Okay, and basically, if you see that, let's see, you can split that. Let's say first one is B, second one is the G, and third one is R. And you can use this computer vision library and split that into 3 parts. Like this is what the array I'm having. And individually, if you see that, it's a 2 by 2. It's a 2 by 2 array. Sorry, it's 2 dimensionary. So this is B matrix, and this is green matrix, and this is red matrix. Matrix is basically the matrix. And if you visualize that, and see, this will talk about the blue region, actual blue region. I'm talking about actual blue region in the image, not in this. This doesn't mean this is not happening. I'm talking about this original image. So let me convert into the grayscale image. Generally put it in the gray so that it's very easy. So this will talk about the blue region. So this is where the blue region is. Wherever the picture highlights, that's the blue. And wherever the picture highlights, this is the green matrix. Wherever the picture highlights, that's the green. I'm sorry. Color map, just changing the color map into the gray. And wherever picture highlights, this is the red matrix. Oh, plt show. Okay, yeah. Okay, this is the red region. The red region in my original image. This is my original image. That's the red region. Okay. So now let's give the definition of the image. What we have understand. Let's try to give the definition of image. Image is a picture created by combination of vectors or values. Right? As you can see, when I read an image, I'm getting some values or some array, vectors or some array. And image is described in terms of vector graphics or raster graphics. Means each and every value specifies some color. I'll coming back to that. And generally, images are stored sometime in the form of raster or bitmaps. Means mostly they're stored in the 8-bit array, 8-bit array, 16-bit array, and 24-bit array, and so on. Bitmaps. And let's say if you take any picture from your mobile phone, right? It's 8-bit. Most of the images that was there in the Google or 8-bit images. Okay. And second thing is that we'll talk about the depth here, 3. The image is a combination of 3 channels. red channel, green channel, and blue channel. Red channel consists of information about the red region. Green channel consists the information about the green region, and blue channel consists about the blue region. If you combine all these things, and you will get this image. If you combine all three matrix, you will get this image. Okay, and if you see, if individually, if you see the red region, this is the red region, green region, and the blue region. Individually, if you see that is what the information what we had: red, green, and blue. If you all combine all together, we will get this. And just try to understand that. Let's say if you consider this image, and I want to evaluate this, or I just want to do some computation, then what it means there are almost 343 and 473, means that many values are there. What I'm trying to say is that if you take this image, there are 343 rows and 473 columns and 3, means the number of values that was there is 343 into 473 into 3, means almost 4,86,717 values I want to process it. So that's why images, text are called big data. Big data, the simple terminology, big data is not all about the size. Of course, size is also matters, but it's also about the speed of operation, processing. See, the size here, it is just 21.8 KB. So that's very, very small size, but still it is called the big data because the volume, the process of what is the speed of operation that I'm trying to do. Because there are so many values out there, this many values I need to process here. Just trying to understand what I'm trying to say. Okay, and the data science perspective, let me put the data science here. Data science perspective, for example, if I want to train the parrot, I just want the information of the parrot. That's it. It doesn't matter, see, let's say if we talk about the numbers, it's in the matrix. See, this image is also consists of parrot. This information consists of parrot, and this information is also this image is also consists of parrot. Data science perspective, if you see, actually what data science actually require, information. Information is what actually required. And if you see that here if I consider color images, I want to evaluate so many matrices. Instead of evaluating so much matrices, what I will try to do is that I'll try to convert that into grayscale. Grayscale is a two-dimensional array, means what we'll try to do is it's a matrix addition, means generally it's a matrix addition. We will add, it's not combining, it's not merging, please, it's adding, matrix addition. We're adding red, some 40% of red, 30% of green, and 20% of blue. We add all together, we'll get the grayscale image. Okay, that's formula, so I'll just keep aside all these things because that's formula. And that grayscale is also an array or matrix which consists the information. And if you see that, this is the color image and this is the grayscale image. And computer only sees that, only the matrix, only the values, that is what the computer interested, not the colors, because computer cannot see the colors. Computer only sees the value. Okay. So most of the image processing applications, mostly will work on the grayscale images. The reason is the computation. Here, if you want to compute for the color image, it's a 3 times. Because 343 and 473, it's a 3 times. Whereas here in the grayscale image, it's not 3 times. We reduce the array by 3 times, so that at least computationally, our algorithm could be efficient. And we can save our computation time, and we can use the computation time for some other purpose too. Okay, so that's the reason of converting into the grayscale. Now, let's try to understand beyond the images. Let's dig deeper into the image. Let me consider this image. It's a number 2, and it's a color image. And the number of rows is 1200, number of columns is 1200, and the size, the depth is 3, means consists of 3 colors. Red, green, and blue. Okay, and I know that we just gone through of course we are not interested actually in the color images in data science. We're mostly interested in the grayscale images. So that's why we just convert that into grayscale and reduce the matrix by 3 times. Now let's talk about a bit about the pixels. Pixels are also known as values. Means if I read this image, means if I read this image, if you can see like, some image, this is what I'm getting, some number. This is what the number, well, let's talk about this numbers now. Okay, the range, see, this numbers has also some meaning. This number, one of the numbers what we got is also has certain meaning here. Each and every number, first let's talk about the range. The range of pixels, the range of pixels is between 0 to 2 to the power of n minus 1. N indicates bit. For an 8-bit image, the range of values is 2 to the power of 8. 2 to the power of 8 is 256. Minus 1 is 255. So the range of values, whatever we're having, is 0 to 255. Here, the range of values, whatever we had here is that it's all of 0 to 255. Okay. Now, okay, 0 is black color. Just try to remember. 0 is black color. 255 is white color. 0 is darker or black color. I'm talking about the grayscale, and 255 is the white color or lighter color. Okay, in the color space, basically it was represented by HSV. H stands for hue, V stands for value, S stands for saturation. Hue will define the color, what color it is. Basically, hue ranges from 0 to circle. Hue is a circle. It ranges from 0 to 360 degrees. It's all about the, I'm talking about the computer colors, how the computer colors are defined, because we require some domain knowledge here. Okay, 0 to 360 degrees. 0 degrees is red color. 120 degrees is green color. 240 degrees is blue color. And some mixing of two colors, like, green, for what is red and green, I'll get yellow. Basically, mixing of two colors, nothing but in computer, we call that angle. If you select 60 degrees, I'm getting a yellow color, and so on. That's what I'm getting. And value, we already understand this value. Value means lower the value is darker, and higher the value, it's original color. Whatever the original color it is, that's what the value means. Lower the values, the ranges from 0 to 255. 0 means dark, and 255 means whatever the original color it is. Saturation, it starts from here. 0 is white color, means and 255 is original color. So like this, we can have the infinite number of colors. That's what we mean. Like we can have all possible number of colors can be possible from this HSV. But of course, we are actually not interested in the HSV here, because most of the image processing applications, like particularly in the machine learning, and we mostly deal with grayscale images. Of course, there are applications, or we also deal with color, but applications are different. Now let's say, let me take this array. For my case, it's an array. Let me take this matrix, and if I take a small portion of this, let's say this is a small portion of that, and this is what I'm getting. 0 indicates maybe some other point I found 0, 230, 255, 53. See, the values whatever having is the meaningful. They are arranged in an order so that we're getting like this. If you're looking from the top view, or if you're looking from the top view, you will get this. But if you go deeper into that, and if you see that, this is what we are getting. This is how the images are created. For example, can anyone tell me, like, what is this? What could be the value in my 2? Like, this is what the 2, right? Some pattern of 2. What could be the value? Some roughly near value. Anyone, please?
0.
Yeah, correct. It's nearly to 0. That value what we had is near to 0. That's how the images are created. Hope you understand. Maybe the concept is a bit complicated, but hope you understand, like, how the images are created. Right. Now let's put the data science here. Data science is process of extracting information from the data. That's what I said. That is what the definition I have given. What information you can extract here? What sort of information you have? What information you had here? That's the point. So basically, I said 3 steps are there: data transformation or data preparation, data analysis, and machine learning model. There are 3 steps are there: data transformation, data analysis, and machine learning model. Okay, data transformation. For the sake of simplicity, only for the sake of simplicity, what I'm trying to do, I'm just trying to compress the image. Let me compress the image. The compression technique that I'm using is inter-area is a technique that I'm using. If you want, you can search in Google what is inter-area technique. Means only I'm taking out the single pixel out of it. That's what the inter-area. So I'm compressing the image only for the sake of simplicity. Maybe it will also work for this image, for this big image also, but only for the simplicity, I'm compressing that image so that it will be easy for you. And the matrix, what I'm having is a 10 by 10 array. This is the 10 rows and 10 columns are there. Okay, the value here is 0, and here are maybe some near to 255 that was there. Now what I'm doing is that, and now this is a 10 by 10 matrix. I'll convert that into either row matrix or column matrix. Means I will flatten it. See, what I'm doing here is that basically, see, this is, I'm expanding all these things, something like this, as I should show in the GIF. I'm expanding, I'm taking that image, compressing it, and taking out the rows, and take all the rows and join. This is what I'm doing here. Okay, if I do this, this is what the image I'm getting. The final image what I'm getting is this. Just what I'm doing, converting in the row matrix and column matrix. Okay, so what is this? How it looks like? Anyone? How it actually looks like? This image. I'm talking about this image. How it actually looks like this? Anyone? It's a barcode, right? It's a barcode. This is how the barcodes are created. Barcode, maybe you can see the barcodes in some places, like, if you purchase any product, you can find the barcode. Everyone knows that barcode is an image and consists of some numbers, some information is there. This is the barcode for number 2. This is how the barcodes are created. This is how barcodes are basically created. It's a 1 by 100 row. It's a matrix, row matrix, and this is how the barcodes are created. And what analysis we can do here? The basic analysis what we can do is that count number of black bars that was there. Maybe here 1, 2, 3, 4, 5, 6, 7. And distance between the bars. From this bar to this bar, what is the distance? Width of the bar. What is the width of each and every bar that was available? Position of the bar, which position these bars are available? What is the range of position that bars are available? And that could be the unique for each and every number. Hope everyone agree with that my statement. That could be the unique for each and every value. What is the values I'm creating for each and every values. This is different. The analysis is all about, and just asking the question. Okay, this is what? How many black bars are there? The distance between the bars, width of the bars. So now we got the answer. We got the insights. Okay, for each and every number, we know that it's unique. And the number of black bars, the distance between the bar, width on the bar, position of the bars, this could be unique. And what else? We can create a simple if and else logic, and that is what the modeling. We can train that. Training the images means taking this barcode. What we are trying to do, taking out this barcode and creating the width of the image. What we are trying to do is that we're trying to just creating rules. Okay, simple if and rules. That is also simple machine learning model. If and else rules is also known as decision tree. One of the machine learning model in one of the machine learning models. Okay, that's how you can train an array. What I'm trying to explain in this example is that pre-processed in such a way it should understand by the machine. Say data is a puzzle, and we have to organize the data in such a way it should be understood by the machine, not by us. We can't understand this, right? We can't understand what this means, but machine can understand. It's easy for the machine to get trained. That is what basically we're trying to do here. That's what actually we're doing. So the point is, data is a puzzle, not for you, it's for the machine. And pre-process the data such a way it should be understood in the machine, not for you. It should be understood in the machine. For you, it is difficult. For you, it is very difficult to analyze. But for you, analyzing is easy. For you, it is difficult to read. But for machine, it is very easy. That is what the steps I'm trying to make, statements I'm trying to make. Okay. Now come to the phase. So far we discussed, these are the steps that was discussed. The step number 1 is converting to the fake, converting the grayscale, and resizing, nothing but compressing, and reshaping. And reshaping means either row matrix or column matrix, transforming, something like this. But just try to understand. Let's talk about converting into the grayscale for let's the statement that I'm trying to the application I'm trying to do is the gender application, like male or female, whether it is a male or it's a female. I can identify, I can identify he's a male or she's a male. So this could be fine. This could be fine. Converting the grayscale, it's okay. But compressing that image, compressing an image, I lose information. I can't do this. If I compress it, I lose information. Okay. If without compressing, if I expand it, face is not a barcode. Unlike image, unlike this numbers, face is not a barcode. We can't train like something like this. But we have to do some kind of transformation. Reshaping, resizing is not possible. But we have to do some kind of transformations here. And finally, we'll build a model. Okay, right. So the recognition algorithm, the structure, the architecture is looks something like this. Let's say I'll take an input image. What I will do here is that I'll detect the face. Detecting the face, I can use either machine learning model. If I want to use a machine learning model, the model I can use is a regression. As I told you, the regression technique, relationship between two or more variables. For that is that I can use the regression techniques to take to build to identify the face, or I can also use this hair cascade classifiers, that is open source hair cascade classifiers out there. Next, once I detect the face, what I will do is that I'll try to identify the landmarks. This and all the landmarks that was there, landmarks means what is the position of eyebrows, what is the position of jaw. And because see, for females the jaw portion is slightly thin. For the males it is it will be broad, and also for the nose, and also all these things will be very, very different for the females and males. So this is what the landmark, this is what the points that I'm trying to extracting. And this I can use again the model regression. The model that I'm using to extract the features, transformations, means I'm trying to extract the feature. What is the position of eyebrows? What is the position of nose, eyes, mouth, and jaw, etc. All these things. That is what I'm trying to extract this. And the model I can use is regression. I use the deep convolution neural network to extract this feature. Now what I'm getting is that here you can see that. See, what I'll try to do is that I got all these points here now. Now what I'll do, I'll try to find the distance between these two. From this point to this point, what is the distance? I'll try to find the distance between all these points. That is what I'm trying to do here. And here the model what I used here is that model what I created is that it will extract the 68 landmarks. Means 68 points will be extracted from here. And what I'm trying, and after that what I'll try to extract here is the distance from point 1 to point 2, point 2 to point 3, and so on. And also I'll take the centroid position of eyes, centroid position of this two eye. This is the centroid position of I1, centroid position of I2, centroid position of nose, centroid position of mouth, and so on. I'll try to find the angle between the centroid. So that is also the unique possible. So like this, I'll compute all possible computation. Once I compute all these things, I'm going to, let's say, assume that I got 128 points I got this. This is what my barcode. This is what my barcode. Okay. And finally, what I can do is that I can create a machine learning model for that. Right. Now, I'm sorry. So basically, what is that? This is what we're trying to do. So I'm sorry. Yeah. Sorry. So first, what we will do, we take an input image, detect the face, and extract the landmarks. And finally, what we will do is that we will take out that distance and all these things, normalized values and all these things. That's what I'm getting. I'm getting the matrix here, 1 by 128. This is what the barcode I'm having with me. I'll train this. Now what I'll do, I'll train this. So let me explain you, like, see what I'm having with me. I'll show you the data. This is what the data I'm having with me, faces, and this and all the female faces that I collected. And similarly, this and all the male faces that I collected here, or female and all the male faces that I collected, all the structure here. So what I'll try to do here is that I'm having the male faces and female faces here. Let me take one image, and the output of that, what I'll get is some vectors, and what I'll get here, so output of that I'm getting some vector. Like this, I'll do it for all the values. So finally, what I'm getting here is that this is for, maybe this is 0.9. This first row is for image number 1, and second row I'll get for image number 2, and so on. I'll put all these things in one matrix. And similarly, I'll give some label like, male, if it's a male, I'll give 1, and if it's a female, I'll give 0. Okay, this is how I prepared the data. Assume that this is how I prepared the data here. And let's discuss about some machine learning algorithm, k-nearest neighbor. It's one of the most simplest algorithm which can able to do. For example, this is what the data I'm having with me. Like, some 60 males or 70 males, something females are there. X1, X2, X3, X4, X5, and 128 values or 128 rows are there here. 128 columns are there, and so many rows are there. Okay, for the sake of simplicity, what I will do is that I'll take only the X1 and X2, only 2 features. And if I plot it, let's say this is what I'm getting, X1 and X2. If I plot it, this is what I'm getting. And this is the category 1, and this is the category 2. Okay, so now what I will do is that, let's say category 1 is male and category 2 is female. And let's say some of the new data point came, like some of you, like, apart from the data point, some new data point is came. I just want to identify it's a male or female. So if I apply the k-nearest neighbor, it can identify. This is what the steps used in the algorithm. So I'm just trying to understand, like, what I'm explaining is only the 20% of the algorithm, and rest 80% is there on different things like distance methods and so much of their computation. What is the value of k, optimal value of k, and so much of this. What are the algorithm explaining? Only 20%. Okay. This is the 4 steps that was there, like, choose the k number of neighbors and so on. Okay, let's discuss step 1 and so on. Let's say this is the data point that was there, and assume that I'll come back to this, y x selected k is equal to 5. Let's say that I'm selecting the k is equal to 5. K neighbors means some 5 neighbors. I want to choose 5 neighbors. 5 neighbors means which are near to it, which are near to this data point. I want to choose the 5 nearest neighbors to it. How to find the 5 nearest neighbors? Basically, distance between 2 points. Which are the distance is lowest? That's what, right? So here the method I use is equivalent distance. Equivalent distance will talk about distance between 2 points. If I have point 1, if I have point 2, and point 1 is x1, y1, and point 2 is x2, y2, and the distance between 2 points is under root of x2 minus x1 and y2 minus y1. Hope you know this, right? Under root of x1 minus x2 and y2 minus 1. This is what the distance between the 2 points which we know, right? Now what I will do is that I'll try to find the distance from all the points. From this point to this point, I'll try to find the distance from all the points. And I got it like, 5 points, right? What I got it is 3 points belongs to red category, and 2 points belongs to 2 points belongs to green category. So finally, what you can do, like, some probability. If you take a probability, what is the probability of red? And if you calculate the probability of green, out of 5, 3 are red. Out of 5, 2 are green. So the probability is 60% probability that it belongs to category 1, and 40% probability that he belongs to category 2. That's it. That's how a simple k-nearest neighbor algorithm works. But here you might ask a question like, why I selected k is equal to 5. Basically, in the binary classification problem, we generally select the odd values of k. Binary classification means like 2 classes. Because suppose if you select the k is equal to 4, there is a possibility that you might end up with 50-50 probability. So that should not be happen. So that's why we select that, 2 categories, that's why we selected 60% probability, and so that's why we select the odd numbers, so that we can get at least, one side we might get highest and second side we might get lowest. So that we may not end up with 50-50 probability. Okay. So this is what the idea that we are trying to do. So I have code is already there with me. Just try to explain you. This is the data I'm trying to use it. like, female pictures are there and the male pictures are there, and this is what I'm trying to use it. And basically see what the idea or architecture that I'm using is this one. First, let me take an input image, detect the face, identify the landmarks using the regression model, and take out the features. These are all my features here. And finally, I'll pass to the machine learning, in this case, k-nearest neighbor, to detect it's a male or female by giving the score to it. Okay, so that is what I'm trying to do. See, this are not all the models are there with me. For example, let me show you the landmark detection model. And maybe the code looks complicated for you. Like this is the code for the landmark detection, and which has the machine learning, it's not machine learning, it's a deep learning model I used so that it will detect, it will take my face and detect my landmarks. So let me execute this. So what actually it will do is that I'm just, this is me. Actually, this is me, and this is me, and this is my face. See what it is trying to do. It will try to detect all my. It will try to detect all my landmarks. This is what the landmarks is trying to do here. Okay. Yeah. So this is what we're trying to do. So, and this is the code that actually I'm having with me. Don't look into the code. Only the process is important for us. The data science process is quite important. It's not about code. Code is very, very easy to understand. It's very, very simple and very easy to understand it. So first, let me import few libraries, and what I'm giving in this case is that, I'm having male and female. For male, I'll put 0, and female, I put 1. Just labeling. This is, I'm preparing the data. This is what I'm trying to do here. Where is it? Yeah, this is what I'm trying to do in this case. Okay, let me execute this. Now, what I'm trying to do, I'm extracting, what is where is the, just giving the path to it. For example, you have data in your database, give the IP address, or if you have the data in your cloud or some platform, just give the URL for that so that we can extract the data. That's what the code. So here you can see that, I'm having the 74 male faces and 64 faces are there with me. Very small data, but still it will work because we are using the very powerful technique k-nearest neighbor, and still, even because we extract the features and k-nearest neighbor, it will work, definitely will work. And if you work on deep learning, it will work for even for the deep learning, but machine learning model is sufficient for such kind of cases, as per as my knowledge. So what I will do now, let me execute this statement. So what I'm trying to do in this case is that, this is what I'm trying to do here. What is this? So this is what I'm taking an input image, detect the face, I'll crop it, and for the cropped face, what I'm doing, I'm trying to calculate the landmarks, finding out the landmarks, and calculate the distance from all the points. And finally, this is what the vectors I'll get, and putting in something like this. This is what the process I'm trying to take an image, calculate the points, and putting it here. Okay, it is quick. I think it's completed. And similarly, I'll do it for one more for the female faces, 64 female faces, and this is for 74 male faces. And same process is being repeated, like same process is repeated. Okay. Yeah, it is done. Now what I'll do, let me convert that into array. And yeah, this is what the shape of array what I'm having. I'm having 130 and 130 rows, means 130 data is available. That many samples are there with me, and 128 features are there. Means that is what we created. This is the data we created now. This is the data we try to create now. Okay. Now what I will do, I will split this data into two parts, training and testing. The reason of splitting the data into training and testing means, see, what are the model I deployed should work for all the values, not only for these images, right? This is what images I train. Not only for these images, for some other images also it should work. That is what the concept of modeling. That is what I have to do here. Okay. The concept of modeling is that. So that's why we'll split the data in two parts, training and testing. For training data, sorry, what I'll do here is that for training data, I'll train my machine learning model. And for the test data, I'll test my model. What is the performance evaluation with this? Means I'll calculate the accuracy, precision rate for that. Okay. So here I'm taking the k-nearest neighbor. The framework that I'm using is scikit-learn. There are so many frameworks out there like TensorFlow, scikit-learn, and PyTorch. Many frameworks are there. Many machine learning frameworks and deep learning frameworks are there. So you can use whatever frameworks you want. For the sake of simplicity, I'm using the scikit-learn framework. And so that is what I'm using. I'm selecting the number of neighbors is equal to 5 here, and fit the model. Let me fit the model. So it's trained successfully. So let me check all my metrics here. And as you can see, that the overall accuracy of the model is 88%. It's quite good. And the precision for 0, just try to understand 0 is a male and 1 is a female. And the precision for female is 80%, means the model has difficulty in identifying the female compared to the male. Okay, that's what we had. And finally, we save our model. Means this is what the model I can save in the pickle format. So why I'm saving the pickle format is because, you know, see, I developed the model in Python. But if I want to deploy in some other applications like, you know, web applications or Android, for web, what I'll use HTML, CSS, and JavaScript. That's what I'll use. But I never. Maybe in the backend I'm using the Python for that. But see, if I want to use it for you know, for all the applications, it should be for universal applications. The pickle is a universal format, just like XML. Any language will accept it, even Python, JavaScript, Java, even in Android. Suppose you want to build Android applications, Android is written in Java. You can also load this application. You can also load this model in the pickle form. It's basically what we are trying to create is XML. Yeah. So it's almost 2 minutes, like 5 minutes. Just hold. I know that. Just hold it, please. So now. Yeah, so we created the application, and so let me create the application here. So I created some application here, like, you know, gender app is there. Because this is connected to my, you know, to my camera, to my web camera, which is connected. So you can see that, and this is the code. What I'm doing, all those things, whatever we learn, extracting the landmarks, everything is there. So that is what you can see. It is detecting me as a male. Okay. So that's how it works, and I'll also show some female pictures in my mobile phone. Yeah, so I have some female pictures. Let me show this to my camera. Yeah, it is detecting as female. Okay. So this is what the idea of the data science. This is what the idea. See, data science. It's a machine learning. There are many machine learning models out there, and deep learning models out there, and so on. Many things are there. But here, the data science or artificial intelligence is all about the process of the model, how to use the model, and so on. Okay, hope you understand, like, you know, how to build this face recognition application. So if you have any questions now, you can ask me. Yeah. This is all about this. Any questions in data in like, you know, the process and flow, you can ask me, please. Any questions? Any questions, guys?
No, we good. That's a little too much to digest on a first day.
Yeah, it's see, that's the data science is, see, it's all about it. I can't explain very simple. It's a very big concept. Yep. Because data science is like an ocean. Like even if you give me 2 more hours, like, you know, even we can explain that. It's not that simple. It's very big, and very small concepts and process. That's what we need to understand in the data science. Definitely, you know, you can create much applications once we know the basic math behind that, how to use this math, and how to create the flows. Obviously, you can create any application, any artificial applications you want. There are many algorithms, so almost in 35 algorithms plus algorithms are there. That is what actually we are explaining in this course. 35 plus algorithms. Each and every application each and every algorithm has its own uses, because it's all about it's not, let's know, many people can understand like what is algorithm, but it's all about like which algorithm we have to use for which application. That's very important. For this, what technique I have to use, for this what analysis we have to use. That's quite important. Yeah. So any questions?
So can we use SVM for this classic, instead of KNN?
I'm sorry?
Can we use support vector machine instead
Yeah,
of
you can use support vector machine. You can use whatever the model you want. Any nonlinear model, it will work. Any nonlinear model. I just don't recommend this logistic regression for this case. And any nonlinear, there's logistic regression or decision tree, it's not recommended. Decision tree is nonlinear, but any nonlinear models like support vector machines, random forest, and any ensemble techniques like gradient boosting, etc., we can be used for this case. It's not only for support KNN, because why I choose KNN, it's easy to explain within 5 minutes. So if I talk about support vector machine, it will take 2 hours for me to explain the math behind that, and we'll talk about the gradients, normalizations, and we have to know about the vector calculus behind this. So that's what it's difficult for me to explain the support vector machine in 5 to 6 minutes.
Okay. I think actually I have to drop, but thank you. The call was pretty good.
Yeah.
Thank
you very much.
Thank
So, thank you very much. Thank you guys.
Thank you. Thank you, everyone. Ishwari will be Ishwari and our Priya will be connecting you all after the session. Thank you all.
Got it. Yeah. Thanks.